Hey guys, I'm Nick and welcome back to my channel. In this tutorial we will be exploring different cool attributes of Vellum hair, and also I will show you a few tips and tricks on how to actually simulate less and get more. Some time ago I saw this artwork by Hanna Villiner and instantly thought about that one attribute that Vellum Sim gives you that is in most cases unused but can give you some unique looking animations. Before we start, I would like to say huge thanks to everyone who supports me by liking and commenting on my videos and maybe even getting my project files, and of course amazing people in our Discord and Patreon community, and in particular Steven van der Linden, Reino Eckstein, Antonin Gebode, Quirin Morhagen, Louis Vigro, Andrew Henrique, Artmel3D, Cody Cho, Peter Sillins, David Othello, Traub, Alex Drosler, Eloy Forrest, Adam Trexler, Karl Hein, Andreas Ludgeb, Ruby Barazani, Pablo Peñapi, Carl Beery, Sam Rossetti, Xeba Canal, May Kanishi, Dave, PL Pen, Ganesh, Lakshmi Gandan, Mohamed Al Abri, Tamas Elias, O Animation Studio, Dalal Al Swair, Renee Gibson, and Matthew Johnson. I'm so stoked that our Cozy Place fam is growing, and by incredible support from my patrons I'm able to do double the amount of patron exclusive tutorials in a month than I actually thought when starting it. Live streams, quick tips, exclusive tutorials, advices, free assets and project files, and all of that on my Patreon and in our Cozy Place Discord channel. Alright, so now let's open up Houdini and see what we've got there. So here's my setup. I'm using one light. I'm using path and collider for that hard shape. I use my hair here and sort of a floor. I'm using Redshift and two cameras. One is our kind of main camera, and this temporary camera is just for zooming in and viewing different things while the Redshift is active, because it's actually requires a camera. I think let's start with the path and collider, because that's kind of like the main thing in our composition. Of course, Vellum is great, but yeah, let's see what we got here. So I started with this hard shape, which is basically an SVG imported into Blender and outputted as an OBJ, because Blender can do that. And then I transform it. It was super tiny. I mean, I scaled it by 600 times. And then I moved the centroid to origin. So basically we have the centroid at the center of the mesh. So then I put it where I want it in the composition and obviously hair grid. And then I just remove everything but the edges. So I remove all the internal polygons, dropping the end SOP, and close U should be set to open. Then I added a dissolve node and basically get rid of everything but just the points. Here I just unchecked remove unused points, because if I check it will remove everything. Then I drop an add SOP, which basically gives me this single polygon, which you can see it doesn't have any connections between the lines, and that's very crucial for our second step, which is resampling. And here you can see I have create only points checked, and we actually don't need these distance and curvy attributes, but let's leave them, maybe we will use them later. And length here is set to 0.11, and you can select, I don't know, maybe 0.9, but yeah, the thing about this is very tricky, because if I visualize the point numbers, you will see that our 0.0 is here. And the expression we will be using to actually guide our sphere, or in this case a little tube, it will start from the frame 0. So we somehow need to get that 0 somewhere here. I wanted it to start from this place here. I don't want it to go from here all the way here, and then I want from the center point, from the frame, actually in this case frame 15. So I know that frame 15 is here, and here in the sort, actually for me nobody of these, like by vertex order, by X, I, Y, Z, all that stuff, it wasn't working. So what I needed to do is just point sort, select to shift, and then manually I see that the frame 15 is here, frame 0 is here, so I just offset. Here you can see that as I'm changing this offset, frame 0 also travels away from our desired location here. And then I add, add a single polygon here, and then I convert it to NURBS curve. If we enable wireframe, you can see that we have this one beautiful curve with all the points in the correct order. So now, how do we actually get something follow the path? In our case, it's this little sort of a tube with closed caps and a bit of remesh. So let me enable up our smooth shaded. And this expression, I found it on Oddforce forums a few, I think, months ago. And it was a very, very old post, like from 2017, I think. But yeah, anyways, credits to this goes to the brilliant people at Oddforce forums. So we drop basically our tube, transform, remesh, pretty default settings. We can enable the wireframe and see that it's pretty ugly, but we don't need anything beautiful here because we don't want to show it. If you want to show it, yeah, maybe then remesh it quite more times and maybe add UVs because you will need them. But yeah, in my case, I want this effect of invisible drawing, let's say. So now what we're gonna do is add a single point, and I am adding it at the 0.7 above the ground because I want the collider not to be colliding with the hair like from the start. You can see that all the way on frame 15 it's 0.2, and basically that's when it touches the hair, so just a little animation. Then we go to the point, and here the magic part starts. So first thing that you will need to do is drop an attribute expression, or actually I think it's called point, right? This one. So what you need to do is go and check this gear and click edit parameter interface, and you will see a bunch of parameters here. So what we need to do is add a float parameter, let's say here, and I already did that, but yeah, whatever. So in the label, that's what you see. So here you don't want any sort of shortenings or something, so you just write position. In our case, it will be position 2 because we also already have position. In the name is what you will be using in like your expressions. So maybe you can use something shorter and faster, so just like pause. In this case, we want to set a range because it will be easier from 0 to 1. And then you click accept or apply, and you will see, let me delete this because I already have it done here. It's our position. So now you can see that we can drag this position. And here in our expressions, what we need to do? Our attribute type should be set to custom, name should be p, and expression should be self plus value. So it's add constant value here. And in constant value, so let me just grab one. So basically what this function does is the function interpolates the value of attribute, and in our case, it's our position at UVW position. So basically what we are doing here is we are interpolating the position of our tube, our little tube here, to the position of our shape. And that results in this follow along path or something animation here. So just want to quickly go through these. Here we set the x value. So p as a vector, we want to grab the first variable or segment of the p, which is x, and then goes here. Then for this one, we want to grab the first one, or actually the second one, which is y-axis. And for the third one, we grab the second one, or actually the third one. Because yeah, it's a bit confusing. In programming, it's 0, 1, 2, and when we like talk about it, it's always 1, 2, 3. And this ch pos is our position, our channel of our position, because its actual name is set to parameter pos. You can see it here. So when I animate this slider, you can see it's moving along the path. And that's basically what I did here from the frame 15. When our tube is already in the hair, we start animating, and I'm animating 120 frames from the 15 to the 135. And I actually wanted to do this specifically pretty fast because I'm using wind to displace the hair a little bit, like to give it just an organic movement or something. And the wind is always too fast for me. Even if I add drag and all that stuff, I always love to kind of retime it or make a slow motion version of it. And that's why I am actually, like, the animation is 240 frames, but this one we're doing all the simulation in the time range of around 120 frames. So then we can extract our beautiful, and like we obviously don't want these first 15 frames, right? I actually started from the frame 30. So yeah, we just grab from 30 to 135 and then I retime these frames, and I know that this is beautiful, slowly moving animation without any sort of glitches or some weird speed or weird wind that only accelerates. So yep. So that's it for the pass and collider. For the floor, it's just a grid. I mean, nothing interesting here. And let's go and check our hair. So this one is pretty cool. All right, as a base, we start with a grid. I add these, again, a bit of hard code, but yeah. So here you can see our grid has 0, 20, 24, and 4. These are point numbers that we wanna go and apply here in the group type shit. Set to points, and then a bit of offsetting, divisions, all that stuff. And of course I subdivided just so we have our smooth edges. And now we generate our base hair. And for this base, actually it's amazing thing how you can remove the stress from your Vellum simulation. So we just go grab our hair generator and we uncheck use guides, segment set to 6, length set to 0.45, and we are doing only 300 hair strands. We add a rest node, we will need it for later, just like add it. Nothing needs to be modified here. Then we go into the guide process, and here in this one I set the length, like operation here set length, and I check this randomize. I really enjoy when they are not that uniform, if like in a real life. So min length 0.4, max length 0.3, and then I love to add a bit of this frizz. Operation set to frizz, frequency 0.6, and it gives these little waves, you know. So that's basically our initial hair. So what we want to do now is create colors for this hair. So now we go and create this Y-pose attribute, basically because I still cannot access this @p.y when coloring here. So we want to create this attribute to store the float value, because position p is a vector, but we want a float attribute from 0 to something. So this add a Y-pose equals to add position point y. Now we go and create colors. Our base color is this yellow color, and color type set to rem from attribute Y-pose, and range 0 to 0.4. And you can see if I visualize it here, here's our basic color. I also want to add this pink color, so exact same thing here, just different colors. Now, as usual with the hair, we want points that will be glued or attached to our surface so our hair won't fall. And here we drop a group expression node, group type set to points, and expression, it's this first point of primitive. You can see that we have our group and it's only the first point of our hair strands. Now we drop a Vellum hair, and here constraint type hair, density, pin to points, pin to animation actually. So pin points group 1, it's the group that we just created here, group 1. Obviously we should name it correctly, I think. So yeah, let's go. Pin points. So pin points here and pin points obviously here. Yeah, let's do the correct way. Pin type should be permanent, orientation same as position. So the main thing that is going to be for this animation is to actually, first of all, for the band stiffness should be set to 0.0001, and damping ratio, and this one is crucial because damping ratio at 0.9 is extremely high value, and this prevents our hair to go up after they were bent. So let me show you. If we go with a default value like I think 0.1. And we will go to the Dopnet in a moment. I just want to simulate, let's say 90 frames. And let's see what we got with the damping ratio set to 0.1. So let's switch to Dop import so it's better to visualize. But basically, I want all of these strands to maintain some sort like this. Let me also remove our collider. So I want them completely to the ground, like here. Here they are bent, like right now at the frame 90. And if we move back, we can see that here some strands are already going up. And this will make at frame 135 the start point when we started to draw our heart. It will be already like less recognizable. So let's move to 0.9 as it was, and let's resimulate that part. Now here you can see that with 0.9, majority of them still stays very, very close to the ground. But of course, this alone will not produce these results. So we should go and add a few nulls. One is geo and one is con, which is connected to our geo and constraints. And we drop a Dopnet. Here in the Dopnet, all is default. I just added a bit of cache memory. And for the Dopnet, let's see what we've got here. So we start with dropping Vellum solver, substep set to 3, and we attach Vellum object, which is also all default. Now we attach Vellum source, and here we specify that subpass is to our geo and constraint subpass is to our con. Now I add just a little bit of really big wind, so swirl size is set to 3, turbulence to 4, and amplitude to 0.3. And also a crucial thing here is a pretty high value of drag. So we drop a pop drag and our air resistance here is set to 2. Actually, if I am dropping pop drag, I would say 0.2, 0.5, somewhere in that range. But here we wanna get these here staying in this to the ground position. So this pop color, we actually kind of don't use it, so we can just remove it. Or if you want, you can just visualize something, but that's not influencing anything. And then we drop all of that into our right input of the Vellum solver. Obviously, we want to add our colliding tube and our ground plane. So for the ground plane, it's all default, just drop it to ground plane, connect it to the merge, and it's good. For the static object, we go and find our pass collider, which is located here in our pass and collider. In here we dropped our null with a naming out collider. So we want to check use deforming geometry, use object transform, create active object, and display geometry. All of that should be checked. And for the physical, I think it's all default here. And then if you simulate this one, let's say 90 frames, you will get this result. So here we have our 90 frames simulated, and you can see how it goes. You see very, very little motion for these strands. So that's the thing that we want in this particular project. So let's go back, and we basically, we have our Dopnet done. So now let's make it beautiful. We want to import what we've done in Dop network. So Dop import node. Here we just drag and drop the Dopnet. You can grab your Dopnet here and just drag here, and it will write down Dopnet 1. We don't want all of the objects, right? We want just Vellum object 1. So by default, it will be like this, and it will output your collider, your ground plane, all of that stuff. We don't need that, so we can click on this drop down here and select Vellum object. I cached 200 frames of this one, so yeah, it looks like this. And now this magic fallback attribute. So in that example, there was kind of like emission setting, I think emission setting for that feedback node. And let me actually kind of visualize it. So what we need to do is, let's go basically, visualize that. So let's go drag here for the color and ramp from attributes, fallback. Fallback is from 0 to 1. So if we visualize, all of the hair is black, and then when we start interacting, you can see how the fallback actually is created. So it's cool to visualize, I don't know, maybe something more like electric or something. But yeah, that's the fallback attribute there. The problem with the fallback is it's only 0 and 1. It's not 0.5 or something. So it's integer attribute. What we want to do is remap to be float. So I drop an attribute wrangle and drop an f, which is float, at b underscore fallback, which is blurred fallback, equals fallback. So we basically made a float from integer. If I visualize it here, it won't do any difference because it's still just 0 and 1. We haven't added anything in between. We just specified that it's a float. Now we drop an attribute blur, and now we grab our b fallback here in attributes. Blurring iteration set to 30, pin border points unchecked, and influence type should be set proximity. Proximity radius in this case is default 0.5 and max neighbors 20. If I visualize this one and plug it into our color, and in our color I should specify b fallback. Oh, and actually I haven't done that when we transformed it to the float, so maybe we will get different results. But nope, as I said, we don't have any in between values. So let's go plug it here, and now you should see how the attribute blur is working. So this one, I really like it, and you can experiment with it, make it even more blurred or less blurred. It's up to you. Let's leave it at 30 at this point. Now, here's this attribute wrangle, and I think it's the best intro into wrangles and vex. So now watch closely. One thing that we want to do to paint this one in pink, we want to create a mask. How do we do that? So we will use attribute transfer. We want to colorize everything to black, and we want to import our out collider. So this is the object merge node, and it brings anything that you specify here. And we go and create this one in red. I think it's because of the lights and materials. It's a bit white's white, but yeah, we colorized all the points to the red here. Now we transfer the color with an attribute transfer. So here kernel radius 0.13, distance threshold 0.01, and blend width 0.1. So if we go and play this simulation here, it's hard to see all the black hair, but yeah, here you can see how we transfer our color. Now, Terror Animator made this tutorial about kind of like sticking that color through the animation. So we drop a solver, and here, let me get back. Here we have our previous frame and our kind of like current frame input 1. So what we can do from previous frame, we drag and drop a connection to the switch node. And here in the switch node, we basically specify that if frame is more than our initial frame, which is 1, we use the current frame. If it's less, we use the previous frame, which is kind of our input from the left into the switch node. And here in the attribute wrangle, really easy Vex code. So previous value is our attribute from the point from the first input, and first input, it's not 0 input, right? It's the first one, so 0, 1, 2, 3. And we plugged our previous frame into the first input, so we grab the color from the point from the previous frame. And then we check that if current color is less than previous value's color, we colorize it to the same as it was in the previous frame. And that's how the color actually sticks. Let me play it. So here you can see that the color sticks to the surface, to the hairs. And that's awesome. That's what we need. Now I want to create an attribute, and I drop an attribute wrangle again. And float mask attribute equals to the red channel of our color. So basically here mask is 1, here mask is 0. Now this magic wrangle. So drop an attribute wrangle. Here, pay attention. So here, our blur feedback, or actually our yellow colored hair, goes into the first input of this wrangle. So here's the hair, it's yellow. Now into the second input goes our pink hair. So here you can see it goes into the second input. And into the third input goes our mask. And I want you to remember that I'm calling them first, second, and third, but in the code, they are represented as 0, 1, and 2. So here, what we want to do is create a vector. I will call it base color. And then we drop this function point, which drives any sort of attribute. It gets that from the point that we specify. So our base color is the color that we read from any point, because wrangle goes through all the points. And we want to read the attribute CD from the zeroest or the first input, right? So that's our base color, that's our yellow color. Then create this vector active color, and then we get a CD attribute from each point of the first or the second, actually the second input, and that's our pink color here. And then from the third, or actually again second, here we specify that it's the second input, but in reality it's this one which goes into the visually third input. I know it's a bit confusing, but then we create this float mask and we drive and get the mask attribute from the third input of each, from the points on the third input geometry. And then we can finally drop an add CD equals linear interpolation, which will interpolate based on attribute from our base color to active color. So basically, wherever the mask, this mask is red, it's 1, it will be active color. Wherever it's 0, it will be the base color. So here, how it works. This was my best explanation of wrangles and vex, and I really think that this one, when we connect multiple items and inputs, this really should click something in your understanding of wrangles and vex. Let me know in the comments if this was helpful or if this was awful. Let me know, I really want to know. So now, drop our Vellum post process and smooth these curves just a bit. So subdivision, Catmull-Clark, subdivision depth 1. And now you see it was pretty cheap to simulate 300 frames, 300 strands. Oh, sorry. So now we want to drop rest again, just rest. And here you can see that we drop another hair gen and we get and connect our subdivided plane as we did, but now we connect it to our hair gen 2. And here in the guides, we connect our Vellum simulation. So if we go to the hair gen here, density here is set to 2000. And for the guides, actually, yeah, we want to use the guide and we want to uncheck grow unguided hair, because here our initial hair is actually a guide for the new hair. And let me show what it actually does. So you see we have much more hair here. It's optional, but I added hair clumps. You maybe want to skip that, but it's all trial and error here. So yeah, just play with that. So then I failed a bit with the camera. So if we set up the cam 1, you can see, maybe you cannot, but here we have a blank spot. So I wanted to move it a little bit so it's all in frame. And then I file cached all of that. I file cached 180 frames, so everything is good. And then I add a retime node. So here I set the evaluation mode by speed 0.5, output frame range from 1 to 240. And input frame range from 30 to 180. So basically at frame 1, if we enable the slow-mo, we are already at frame 30. So if we enable the slow-mo, you can see how it all goes to the frame 240. And then, a good practice, null, and in this case, out hair. All right, so now let's open up Material Editor, Lights, and see how I actually set all of that up. So for the RS light, it's one light, which is pretty big, and it is located here. For the camera, its focal length set to 120. For the material network, and this is a bit tricky there, but yeah, whatever. Let's do it. For the collider material, I thought that I will be using anything, but nope. The collider material is actually not used because the collider is not visible. For the grid is just like this gray yellowish dark color with a 0.8 for the roughness, and here for the hair. So you see, we actually could just plug this particle attribute lookup into the diffuse channel here, and we will have this harp. But I actually wanna add our blurred fallback. So what I need to do is to create RS color mix, and in a mix amount, I want to drop the particle attribute lookup, and here in outscaler, we connect the outscaler to mix amount, and attribute name here is B fallback. And what it does, it creates this, in this case, I'm mixing this dark red with the actual color on the hair. So this color, right? I'm mixing that, and when I don't know if you can see it. Yeah, obviously you can see that, but because that's material. So let me start the render. So here you can see our fallback. So this little red pigmentation, or how do you call that? It's actually our fallback. So that's what I wanted to do. And here in the MatNet, so we have our fallback here, which controls the amount of mixing plain red color, which is here, and our actual color from like CD that we plug into our input 1. And then, yeah, we just plug that into our diffuse channel and roughness set to 0.364. Now let's enable our floor. So yeah, I think that's it. I rendered that as a PNG with an automatic sampling turned off, min samples 512, max samples 248. It was pretty hard to render it out. I mean, took a bit of time, even on farm. So global illumination 8 and 2024. And yep, I think that's it. Alright guys, I think that's it for this little tutorial. I really hope you enjoyed it, and if you learned something new, leave this video a like, drop me a comment, and definitely check out my Patreon. You'll find many more tutorials there, project files, assets, all of the good stuff, and most importantly, our Discord community. I'll be back very soon. Bye!